Okay, so we're going to look at a few applications of integration. First couple examples are kind of science related. The other ones after this will be, we're looking at some more specific AP problems. So this one here, work is calculated by Newton's meter, so force times distance moved. In this particular problem, the force is given by the function, force as a function of how far we move. So as you move the object, the force that you're using changes. So we need to figure out how much force or how much work is being done from 0 to 5 meters. Okay, so this is an integration problem because if you kind of imagine this problem, force this way, meters this way, that area calculated is going to be Newton times meters, which is work. Okay, so the area underneath this curve is going to be work. I don't really know what this curve looks like, but we're going to integrate this. So the work done is going to be the integral from, it looks like 0 meters to 5 meters of this function. So this is all in terms of the correct variables. I need to be able to use substitution here to be able to integrate this, and I can. So I'm going to let u is equal to meters squared. So du over 2 is equal to m dm. Okay, I move the 2 down to below. So I can change this from m equals 0 to m equals 5 meters. Okay, this is going to be sine u du over 2. So I'm going to put the 1/2 on this side. And now I can integrate this. So the work done is going to be calculated by 1/2 cos, negative cos u from m equals 0 to m equals 5. Okay, I can change it back into n variable. So it's going to be cosine of meters squared from 0 to 5. Plugging that in, I get negative 1/2 cos 25, I'm not sure what that is, minus cos 0, which is 1. Okay, so this is the work done as a function of distance traveled. Okay, this one is called the probability density function. The probability density is that the area underneath the probability curve is equal to 1, or the likelihood of anything happening is 100%. And the area underneath the curve represents probabilities. So this function here, well, I'm going to graph this because I should really sketch what this graph looks like. So I'll grab my graphing calculator here. So my equation is x cubed divided by 5,000 and 10 minus x. Okay, so if I take a look at this function, it's from 0 to 10. And the area underneath this curve, I need to change my windows a little bit here. Okay, so I'm going to have a curve that kind of looks, this is just generally, it's going to look kind of like that. Okay, so there's my curve from 0 to 10. I want to find the probability from 3 to 5. Okay, so basically I want to find the area underneath this curve from 3 to 5. Okay, so first of all, we want to show that this is in fact a probability density function by actually integrating and showing that the area underneath the whole curve is equal to 1. So I'm going to integrate this. The area is equal to from 0 to 10. And I want to show that it equals 1. So I'm going to end up with, what would this be? X cubed over 500 minus x4 over 5,000. Okay, when we anti-differentiate this, we're going to get x4 over 2,000 minus x5 over 25,000. Okay, and this is going to be from 0 to 10. Okay, so when I plug that in, I'm going to get 10,000 over 2,000 minus 100,000 over 25,000. Okay, so this is going to be 5 minus 4, which is equal to 1. Okay, so the area underneath that curve is 1. This is in fact a probability density function because the property of probability density function, the area has to equal 1. Okay, so that's the first part. For part B, we want to show that the area underneath this curve, we want to find out the area or the probability of something happening between the measurement of 3 and 5. So we're going to then calculate the area, do the same thing, but do from 3 to 5, okay, of x cubed over 500 minus x4 over 5,000 dx. Oops, forgot my dx in there. And then we're going to get the exact same function. So from 0 to 10, sorry, not from 0 to 10, from 3 to 5. Okay, so then working this out, we're going to end up with, I think that works out to 625 over 2,000 minus 5 to the power 5 is 3125. 3125 over 25,000, okay, minus 81 over 2,000 minus, that's going to be 243 over 25,000. Okay, I'm just going to plug that into my calculator. Okay, so that's going to be it's taking me a while punching this into my calculator. Okay, so my final value that I get here is a probability, works out to be about 15%. Okay, so that area underneath that curve represents about 15% of the entire area underneath that. The red area represents about 15% of the entire area underneath that curve, which is 100%.